Most of what we're going to do with today's material is focus on different reactions that alkenes can do. And you are going to learn about 4 different reactions of alkenes. The first reaction that you're going to learn is called hydrogenation. And the way that we're going to organize this, the way that we're going to lay it out, is I'm going to show you a reaction, a generic version of the reaction. So what I'm going to do is say, let's say that we have a molecule that has a carbon-carbon double bond, so it's an alkene. And there's going to be stuff attached to these carbons of the alkene, but it doesn't make any difference what those things might be. These things out here, they could be anything at all. So we're just going to make little question marks. Because no matter what the molecule is, as long as it has this carbon-carbon double bond, it's going to react the same way. And so in the hydrogenation reaction, our alkene reacts with a molecule of hydrogen gas. And a molecule of hydrogen gas is H2, contains 2 hydrogen atoms. And the product of this reaction, the way that the reaction works, the carbons of the alkene, their bond is changed from a double bond to a single bond. The things that were originally attached to those carbons, they're still there. They haven't changed at all. So whatever was hanging off of it is still there. The 2 hydrogens from the H2 molecule, these 2 hydrogens right here, they end up attaching themselves to the 2 carbons of the alkene. So they end up here and here. This reaction works really well in the lab, but it does need to have a catalyst, and the catalyst is going to be a metal like platinum. And the way that we write a catalyst into a chemical equation is, like I just did, by writing the formula for the catalyst under the arrow. So PT, let's make a note of that over here. PT is catalyst. That's the symbol. PT is the atomic symbol for platinum, which is a common catalyst for this. You can also use palladium, which is PD, or nickel, which is Ni, and you're always going to see them written underneath the arrow. So this is what we just drew here, is just a really generic version of this reaction. Now let's draw it with an actual alkene molecule. So we're going to start with a pretty simple alkene. And I'm going to write this equation a little bit differently. So instead of writing plus H2 and then the arrow, I'm just going to go straight to the arrow. And I'm going to write the H2 on top of the arrow and the catalyst on underneath the arrow. And I'm going to stick with platinum. It's pretty normal in organic chemistry for us to use this type of notation, where instead of writing plus H2, we just write H2 on top of the arrow, and it just saves us a little bit of time. But whenever you see that, whenever you see something written on top of the arrow, like we have up here, just assume that that means plus H2 or plus whatever it is that you're looking at. And so to draw the product of this reaction, what we're going to do is draw the alkene, leave everything there exactly the way that it was, but change that carbon-carbon double bond to a carbon-carbon single bond, and add the hydrogens from the H2 molecule. So there they are right there. Now for both of these examples, in both cases, I drew the hydrogens pointing down coming off of those particular carbons, but there was no reason for that. I just did that because I felt like it would look pretty to draw them in that direction. You can draw them pointing wherever they fit, wherever you would like to draw them. So what we're going to do now, before we move on to another reaction, let's go to the worksheet for this section 13.6. And on this worksheet, the first three problems of the worksheet are practicing this first 4 problems are practicing the hydrogenation reaction. So let's just practice it right away. Now, one thing that's a little different with these ones is that our reactant is given to us in a line structure instead of written out as a Lewis structure or a condensed structure like I just did. When we are doing hydrogenation reactions using line notation, the reaction products are even easier to draw because remember, we don't actually draw hydrogen atoms into the line notation. So when we look at this particular reaction, we can see we have H2 on the top, so that means plus H2, we're adding H2. This guy down here is our catalyst underneath the arrow. And so that means that all that we're going to do is leave the whole molecule intact, but change that carbon-carbon double bond to a single bond. Which, there it is. Because we don't have to draw the hydrogens onto a line structure, we're not going to have to actually draw them in. So this reaction is super easy when we're doing line structures. Let's look at the next one. Here is our reactant, and we want to redraw that molecule, leave all of the bonds intact, but change the double bond to a single bond. This is really easy, right? Which you deserve, because the cis-trans stuff is really hard. So you deserve to have something that's kind of easy. Let's do the next one. Draw the molecule, leave everything where it is, but change the double bond to a single bond. These reactions should be making you feel happy, because you can do this. Here's one more example. Draw the molecule, leave everything where it is. We're not going to change the location of anything at all. The only thing that we change is the double bond turns into a single bond. Now, as I'm looking at this worksheet, I can see that I did change the problem, or the problems on the worksheet, but I didn't change the instructions on the top. So the instructions on the top are referring to alkynes, and we're not doing alkyne reactions. Just cross those off, sorry about that. No alkynes. Okay, so there's our hydrogenation reaction.